Hi students, this is T. Balakrishna, Chemistry Lecturer, GPT Kothagudem. Today our topic is neutralization reaction. The reaction of an acid with equivalent amount of base to form salt and water is called neutralization reaction. According to the arrhenius theory, a neutralization reaction defined as the reaction between acid and base. If it is produced salt plus water, that is called neutralization reaction. We already learned in previous part the general formula of the acid is HX and the general formula of the base is MOH. So it is an acid, the general formula of the acid and general formula of the base. The acid is react with base. Acid is react with base. It produces salt plus water. So the acid is contain H plus ions and X minus ions. The base is contain M plus ion and OH minus ions. Okay. So if acid is react with base, this M plus is react with X minus, it produce MX. This H plus is reacted with this OH minus. If H plus and OH minus, it produce H2O, water molecule. H plus and OH minus giving rise to H2O. So we will get MX plus H2O. MX plus H2O. So this we already learned MX is a general formula of the salt. This is no water. Okay. If the acid is react with base, it produces salt plus water. That reaction is called neutralization reaction. In which reaction the acid is react with equal amount of base, it produces salt plus water. Such type of reaction is called neutralization reaction. Take one example. For example, we know the general formula of the acid. The simple example for acid is HCl. If it is react with simple base, just well known example for base is sodium hydroxide. So if it is react with each other, it contain H plus and Cl minus, M plus and OH minus. This Na plus is combined with this Cl, you will get NaCl plus H plus and OH will get H2O. So this is an acid. This is react with base. It produces NaCl salt plus water. Is it clear? Right. In which reaction an acid with an equal amount of base, an acid is react with equal amount of base and form a salt and water. That is called neutralization reaction. This is the general formula of the acid. This is the general formula of the base. This is the general formula of the salt. That is a neutralization reaction. Is it clear? The acid is react with equal. According to the Arrhenius theory, the neutralization reaction is defined as an acid is react with equal amount of base. If it is produced salt plus water, that reaction is called neutralization reaction. In this reaction, acid contain H plus ion, bases contain OH minus ion. Both are combined to form water molecule. That is neutralization reaction. Next our topic is strength of acids and bases. The strength of an acid or a base in Arrhenius concept is based on rate of ionization or an equilibrium constant of an acid base. Is a strength of acid. So if it is an acid, uh, if you want to say the strength of acid, that means it is a strong acid or weak acid, or strong base or weak base, is depending upon the rate of ionization. We already learned the general formula of acid is Hx. General formula of the acid is Hx. So when it is split into ions, it produces H plus ion and X minus ion. If you want to tell the strength of acid, it is depending upon rate of ionization. Here, dissociation constant, it is represented as K. Dissociation constant of A acid is equal to concentration of products by concentration of reactants. Concentration is represented in bracket. So concentration of products H plus ion and X minus ion by the concentration of reactants Hx. Here strength of acid is depending upon dissociation. ఎంత అయితే స్ప్లిట్ అవుతుందో అన్ని అయాన్స్ వస్తాయి, దట్ ఈస్ రేట్ ఆఫ్ అయనైజేషన్. డిసోసియేషన్ కాన్స్టెంట్ ఆఫ్ యాసిడ్, ద ఫార్ములా ఈజ్ స్ట్రెంత్ ఆఫ్ concentration of reactants by concentration of products. So if the Ka value is 1, that is a strong acid. That is strong acid. Okay, if the Ka value is less than 1, that is weak acid. That is weak acid. Is it clear? The Ka value is equal to 1, that is a strong acid. Ka value is less than 1, that is a weak acid. So it is strength of acid is depending upon rate of ionization. Rate of ionization is depending upon dissociation constant. So I take simple the general formula of the acid. If you want to find out the strength of HCl, so it is split into H plus ion plus Cl minus ion. So Ka of HCl is equal to K of H plus and as the concentration of H plus ion minus H plus and concentration of Cl minus by concentration of HCl. So that is a dissociation constant of hydrochloric acid. This HCl have Ka value is equal to 1. So it is an example for strong acid. Is it clear? The strength of bases. The strength of bases in arrhenius concept based on rate of ionization. The rate of ionization is depending upon dissociation constant of base. We already learned the general formula of the base is MOH. It is split into M plus and OH, M plus and OH minus. It produces OH minus, so that is a base. So if you want to tell if it is an acid, strong base or strong acid depending upon rate of ionization. If it completely ionized, that is a strong acid. So there is a formula to calculate the strength of base. This K is the dissociation constant of, it is in a base Kb. So is equal to concentration of products by concentration of reactants. The concentration of products are M plus and O minus, OH minus by reactants MOH. The which base have Kb value is equal to 1, that is a strong base. That is a strong base. Okay. The which base value is less than 1, that is in a weak base. That is in a weak base. The Kb value is equal to 1, that is a strong base. Kb value is less than, that is a weak base. The rate of ionization, depending upon the rate of ionization, strength of acid is defined as the which acid is almost completely ionized, that acid is called strong acid. Which acid is partially ionized, that acid is called weak acid. First it should be acid. If it is almost ionized, that is strong. If it is partially ionized, that is a weak acid. Is it clear? If it is in a base, the base is completely ionized and produce more number of OH minus ion, that is called strong base. The which base is partially ionized and produce less number of OH minus ions is called weak base. The base, the acid which is almost completely ionized and produce more number of H plus ions is called strong acid. The acid which is partially ionized and produce less number of H plus ions is called weak acid. So an example for strong acids. Example for strong acids: HCl, HNO3, H2SO4. Example for weak acids: CH acetic acid, phosphoric acid. Example for strong base: sodium hydroxide and potassium hydroxide. Example for weak base: ammonium hydroxide and magnesium hydroxide and lithium hydroxide. Okay, is it clear? Which acid is completely ionized and produce more number of H plus ions is called strong acid. The which acid is partially ionized and produce less number of H plus ions is called weak acid. The which base is completely ionized and produce less number of OH. Which base is completely ionized and produce more number of OH minus ions is called strong base. Which base is partially ionized and produce less number of OH minus ions is called weak base. I repeat, which base is almost completely ionized, produce more number of H plus ions is called strong acid. Which base is partially ionized and produce less number of H plus ions is called weak acid. The which base is almost completely ionized and produce more number of OH minus ions is called strong base. Which base is partially ionized and produce less number of OH minus ions is called weak base. And example for strong acid, an example for weak acids, an example for strong base, an example for weak base. Next our topic is limitations of Arrhenius theory of acids and bases. Limitations of Arrhenius theory of acids and bases. According to the Arrhenius theory, the definition is the substance which produce H plus ions in aqueous solution. The substance which produce H plus ions in aqueous solution, that means H2O, that is called acid. The substance which gives OH minus ions in aqueous solution, that means water, that is called base. The substance neither nor give H plus ions or OH minus. That means it produces M plus or X minus. Neither gives H plus ions nor OH minus ion. That is called salt. When you observe these definitions, um, uh, it is depending upon water, aqueous solution. This theory is applicable to only aqueous solution. When the substance is added to the water or dissolve the water, if it is produced H plus ion, that is acid. If it is produced OH minus ion, that is base. If it is gives neither nor H plus ions and OH minus ions is called salt. అంటే నీటిలో వేసినప్పుడు H plus ions ఇస్తే యాసిడ్, OH minus ions ఇస్తే బేసు, ఆ రెండు ఇవ్వకపోతే సాల్ట్ అని చెప్పాడు. అలా కాకుండా నీటిలో కాకుండా ఇంకా వేరే దాంట్లో వేస్తే ఒకవేళ H plus ions ఇస్తే ఏంటి, OH minus ions ఇస్తే ఏంటి, ఇవ్వకపోతే ఏంటి అనే విషయాన్ని అర్హీనియస్ అనే సైంటిస్ట్ ఎక్స్ప్లెయిన్ చేయలేకపోయాడు. అంటే ఈ థియరీ ఎక్కడ అప్లై అవుతుంది, ఓన్లీ ఆక్వస్ సొల్యూషన్స్ ఉన్నప్పుడు మాత్రమే అప్లై అవుతుంది. దిస్ థియరీ ఈజ్ applicable to only aqueous solutions only. If the substance is produce H plus ions in aqueous solution, that is an acid, the substance produce OH minus ions in aqueous solution is called base. It gives neither H plus ions nor OH minus ions in aqueous solution is salt. So that means its theory is applicable for only aqueous solution. That is the first limitation of Arrhenius theory. Come to the second limitation. It is failed to explain the acidic character of CO2 and SO2. By experimentally proved that CO2 and SO2 have acidic nature. But according to this theory, the chemical substance which produce H plus ions is called acid. ఏదైనా ఒక కెమికల్ సబ్స్టెన్స్ H plus ions ప్రొడ్యూస్ చేసినప్పుడు మాత్రమే దాన్ని యాసిడ్ అంటాం. కానీ CO2 కనుక స్ప్లిట్ అయినా ఏమైనా మనకి H plus ions వచ్చే అవకాశం ఉందా, లేదు. SO2 కనుక అయనైజేషన్ అయినప్పుడు కానీ వాటర్లో డిజాల్వ్ చేసినప్పుడు H plus ions వచ్చే అవకాశం ఉందా, లేదు. ఎందుకంటే దాని దగ్గర లేవు కాబట్టి. అందుకే మనం జనరల్ ఫార్ములా ఆఫ్ ద యాసిడ్ చెప్పుకున్నాం ఇంతకుముందు. ద జనరల్ ఫార్ములా ఆఫ్ ద యాసిడ్ ఈస్ HX. when it is split into acid produce H plus and X minus. H plus ion ప్రొడ్యూస్ చేయాలంటే దాని దగ్గర కంపల్సరీ H అనే ఆటమ్ ఉంటే అది వాటర్లో డిజాల్వ్ చేసినప్పుడు H plus ion ప్రొడ్యూస్ చేస్తుంది. అలా ప్రొడ్యూస్ చేస్తేనే దాన్ని మనం యాసిడ్ అంటాం. కానీ ఇక్కడ CO2లో H అనే ఆటమ్ లేదు కాబట్టి అది H plus ion ప్రొడ్యూస్ చేసే అవకాశం లేదు. కాబట్టి అది యాసిడ్ అయి ఉండే అవకాశం లేనే లేదు. బట్ ఎక్స్పెరిమెంటలీ ప్రూవ్డ్ దట్ CO2 an acid. So these theories fail to explain the acidic character of CO2. Same as SO2 also show the acidic nature, but according to this theory it should produce H plus ion. There is no chance to produce the H plus ion. So this theory failed to explain the acidic character of some molecules and elements which not have hydrogen atom. వాటి దగ్గర హైడ్రోజన్ ఆటమ్ లేకపోయినప్పటికీ అవి ఎసిడిక్ క్యారెక్టర్ చూపిస్తున్నాయి. ఈ థియరీ ప్రకారం దాని దగ్గర హైడ్రోజన్ అనే ఆటమ్ ఉండాలి. అది అయనైజేస్ అయినప్పుడు వాటర్లో కంపల్సరీ H plus ion ప్రొడ్యూస్ చేస్తారు. అలా చేస్తేనే ఈ థియరీ ప్రకారం యాసిడ్ అంటాం. కానీ CO2, SO2 లాంటి ఎలిమెంట్స్లో అటువంటి నేచర్ లేకపోయినప్పటికీ అవి ఎసిడిక్ క్యారెక్టర్ చూపిస్తున్నాయి. దట్ ఈస్ ద సెకండ్ లిమిటేషన్ ఆఫ్ అర్హీనియస్ థియరీ ఆఫ్ యాసిడ్స్ అండ్ బేసెస్. కమ్ టు ది third limitation. This theory failed to explain the basic character of NH3. We already learned the definition of base according to the Arrhenius theory. The chemical substance which produce OH minus ions in aqueous solution in water, that is called base. So it should contain hydroxyl molecule. It should contain hydroxyl molecule. So it contains hydroxyl molecule. So it is split into ions. It produces OH minus ions in aqueous solution, that is called base. సో ద కంపల్సరీ అది బేస్ అయి ఉండాలంటే దాని దగ్గర హైడ్రాక్సైల్ అనే మాలిక్యూల్ ఉండాలి. అందుకే జనరల్ ఫార్ములా ఆఫ్ ద బేస్ ఈస్ MOH. ఇట్ ఈస్ స్ప్లిట్ ఇంటూ M ప్లస్ అండ్ OH మైనస్. సో ఇఫ్ ఇట్ ఈస్ ప్రొడ్యూస్ OH మైనస్ అండ్ దట్ ఈస్ కాల్డ్ బేస్. దీన్ని బట్టి మనకి ఏమవుతుంది, కంపల్సరీ దాని దగ్గర హైడ్రాక్సైల్ మాలిక్యూల్ ఉండాలి. అది వాటర్లో వేసినప్పుడు OH మైనస్ అయాన్గా అయనైజ్ చేస్తేనే దాన్ని బేస్ అంటాం. కానీ ఇక మనం తీసుకున్న ఎగ్జాంపుల్లో NH3 there is no chance to produce the OH minus ion because it not have any hydroxyl molecule, but experimentally proved that it is a base. And calcium oxide, there is no chance to produce the hydroxide ion, but it experimentally proved that it shows basic nature. So according to this theory, it should have hydroxyl molecule. It is ionized into water, ionized in the water and produce hydroxide. Such type of molecules is called bases. But ammonia and calcium oxide not have any hydroxyl molecule. There is no chance to produce hydroxyl ion in water. So according to this theory, they are not bases, but experimentally proved that they are bases. So this theory failed to explain the basic nature of ammonia and calcium oxide. Is it clear? There are three important limitations. One is this theory is applicable for only aqueous solutions only. The definition of acid and base according to the arrhenius theory is which produce H plus ions in aqueous solution, which produce OH minus ions in aqueous solution. The main word is aqua. So the theory only applicable for aqueous solution. For example, HCl is dissolved in water, is produced H plus ions, that is called acid. For example, the substance is dissolved in petrol, if it is produced H plus ion, అలా ప్రొడ్యూస్ చేస్తే దాన్ని ఏమంటారో చెప్పలేదు. ఇప్పుడు ఇస్ డిజాల్వ్ ఇన్ బెంజిన్, ఇస్తే ఏంటి ఇవ్వకపోతే ఏంటి ఏమీ చెప్పదు. ఎక్కడ చెప్పాడు? ఓన్లీ ఆక్వా సొల్యూషన్లో వేస్తే హెచ్ ప్లస్ యాన్స్ ఇస్తే యాసిడ్, ఓహెచ్ని ఇస్తే బేసు, ఆ రెండు ఇవ్వకపోతే సాల్ట్ అని చెప్పాడు. అదే సబ్స్టెన్స్ తీసుకుపోయి పెట్రోల్లోనూ కిరోసిన్లో వేసినప్పుడు హెచ్ ప్లస్ యాన్స్ ఇస్తే ఏంటి ఇవ్వకపోతే ఏంటి అనేది చెప్పలేదు. అంటే ఈ థియరీ ఎక్కడ అప్లై అవుతుందంటే ఓన్లీ ఆక్వా సొల్యూషన్స్కి మాత్రమే అప్లై అవుతుంది. This theory failed to explain the acidic character of CO2 and SO2. According to this theory, which produce H plus ion, that means it should contain hydrogen atom. So that means this theory failed to explain the acidic character of some acidic elements which does not have hydrogen atom. Okay, this theory failed to explain the basic nature of some basic character molecules which does not have hydroxyl molecule. హైడ్రాక్సైల్ ఈ థియరీ ప్రకారం దాని దగ్గర హైడ్రాక్సైల్ మాలిక్యూల్ ఉండాలి. అది వాటర్లో వేసినప్పుడు అయనైజ్ అయినప్పుడు ఓహెచ్ మైనస్ అయాన్ రావాలి. అలా వస్తేనే ఈ థియరీ ప్రకారం దాన్ని బేస్ అంటాం. కానీ కొన్ని మాలిక్యూల్స్ వాటి దగ్గర హైడ్రాక్సైడ్ అయాన్ లేకపోయినా అవి బేసిక్ నేచర్ చూపిస్తున్నాయి. అలా బేసిక్ నేచర్ చూపించడానికి గల రీజన్ని అర్హీనియస్ అనే సైంటిస్ట్ తన థియరీలో ఎక్స్ప్లెయిన్ చేయలేకపోయాడు. కాబట్టి దిస్ థియరీ ఫెయిల్డ్ టు ఎక్స్ప్లెయిన్ ద బేసిక్ నేచర్ ఆఫ్ ammonia and calcium oxide which does not have hydroxyl molecule in the molecular state. These are the limitations. This theory failed to explain the acidic nature of CO2 and SO2. This theory failed to explain the basic nature of ammonia and calcium oxide. This theory is applicable to only aqueous solution. Okay, this is T. Balakrishna, Chemistry Lecture, GPT Kothagudem. Thank you students.